I'm in Minitab and I'm looking at the blink data, and I'm just going to go through getting some of the descriptive statistics out for this data set. One of the things I do like in Minitab is that I can just go through and get it to tile all of my windows for me, just to see if I want to delete any of them. So if I just go to tile, I get a nice little picture of each of them, and then I might go through and just delete the ones I don't want. That was quite loud. Do I want to save it in a separate file? No, that's fine. I won't do any more. Okay, so now I'm in my output window because I'm going to start outputting these descriptives for each of the data set. So when I was looking at this pie chart, for instance, I could see that there were slightly fewer people tested inside than outside, and that's a nice way of just showing what happened. But if I want the actual numbers, then I need to get them tallied up, and Minitab will count those for me. So if I go to Stat, and I'm interested in tables, and I would like to just tally the individual variables. So we could actually tally each of our categorical ones, so eye cover, gender and area. We're not going to be interested in tallying up any of our continuous ones. I can show you why in a second actually if you like. Let's just do these ones first. Oh, I haven't actually selected them. Either double click them or you highlight them and then press select. Okay. So if I open up my output window, I wonder if I can make that font a bit bigger. I'll just pause for a second and see if I can make that font bigger. Okay, I've remembered where to do it. I used to mess around with my Minitab files a lot just to really customize my graphics. If you go to Tools and Options, I think it was. Now if we go into, you've got a whole lot of options here for graphics. If you want to change the default colors, for example, the default size, it can take a little bit of time actually. You can get lost messing around with things and then trying them out. But I'll just go into the session window and look at the font. Let's try and get that much bigger. There we go. So that's easier to read, I think. Now, I haven't done anything yet. Oh, I have. I've tallied. So let's have a look. Tally of eye cover. So I'm down here. We can see that we've got, under eye cover, we've got glasses had 10, lenses had 3, which is not many, and people with no eye cover was 101, and we've got a total of 114 people. In gender, we had 54 female and 60 male, so we had an approximately even split there, not much of a difference. And again, with the area inside or outside, we have 56 inside and 58 outside, and that's a fairly even split too, which is nice. So that's just counting up the numbers in each categories. We might be interested in doing what's called a cross-tabulation, where we see how many females and males there were in each of the areas. And we'll go to Stat, Tables, Cross-Tabulation. It's just popped up on the other screen again. It doesn't matter too much which one you choose for rows and columns. I would suggest you probably don't separate it into layers at this stage. Each time you put another variable in, you split your data up more and more, and it becomes a little bit difficult to work out what's going on. So for rows, let's just try gender, and then for columns, eye cover. Okay. So now we can see that we've got, I meant to do area. I've done eye cover, that's alright, we'll stay with that. So females we had 4 with glasses, and males we had 6 with glasses, 2 females with lenses and 1 without, and then the large number without any eye cover at all. We probably won't be able to do anything much with this data because the numbers are so low. However, I mean, if this was a serious research question, then this might be something that you then use as a basis for a further study, where you deliberately go out and sample more people who have eye covers to see if there's a difference in the time they could hold their eyes open. But obviously this is not a question of huge importance in real life. If we just try it again, we can have a look at, where am I? Cross-tabulation. It keeps popping up over the other side. Drag it across. it's not eye cover I want. Let's delete that. I want the area. I just want to check they had a roughly even split in the areas. So inside, outside, female and male. We've got 22 females in and 32 out, 34 males in and 26 out. So it's not an equal split, but they've still got a fairly large sample in each group. So that's good. Now I did promise to show you what would happen if you put the wrong type of variable into the tally. So let's have a look at that. Let's take out those. I'll just press delete and I'll put in time. Now you can see what it's doing is it's counting up the number of times it gets each observation, and because it's a continuous variable there's loads of minute differences between each of these observations, and that's why you wouldn't tally up anything that's continuous. Occasionally you happen to get two people that get exactly the same response, but for the most part you get one in each. So if you get into a situation where Minitab spits out a huge array of numbers, it's quite possible you've done something a little bit silly. So that's tallying up and cross tabulations, and that's what we would do with categorical variables. If we were exploring our continuous variables, we'd stay with the basic stats, which is the first option, and have a look at the display descriptive statistics. Now I like this one if you're still choosing between Minitab and SPSS. Actually, a lot of these things are just a little bit easier in Minitab, I find. So if we just want to have a look at the variables overall, we can just pick them, and you can see here I've put time to sleep, so it's time, age and sleep all together. Okay, now it gives us each of these variables, the number of observations in each one, N star is the, I can't remember exactly what Minitab does with this, probably the ones, mine must be the missing data actually, because it's at 0. I was trying to remember if that was the effective observations or the missing, but I think it must be missing. So what can happen is that sometimes you'll be missing data in various parts. So it's possible you'd get a participant who was, say, willing to do the test and hold their eyes open, but they couldn't remember how much they slept the night before, or they didn't want to tell you how old they were. So you would still have 114 people participating, but you would be missing one bit of data in one of these rows. Then we have the mean. So this is the average time, 21 seconds on average. Average age was 23 and average sleep was 6.8. It'd be interesting to know what the national average for sleep was actually, whether or not students get less sleep than people in general. The standard error of the mean we haven't done yet. Standard deviation, so this is a measure of how much variation there is in the data. There's quite a lot of variation in this data. And we can look here at the exact minimum and maximum values, whereas we could only see these approximately on the graphs, but now we can see that the minimum time someone could hold their eyes open was 2 seconds, which seems to be really, really short. And the maximum time was 125 seconds, which seems to be really, really long. And then we have the minimum sleep was 0, which is a bit of a worry that someone's been up all night. And the maximum sleep was 11 hours. So I wonder if that was a child. That seems like a lot of sleep. And again with the age, we've got a minimum age of 2. I don't know why they experimented on children. That's not ethical. You really can't go around experimenting on children. Given that they were on a university campus, it's possible that it was actually their own children that they brought in to do the project with, or perhaps there was a parent there that was happy to run the experiment with their kids. But due to the ethics regulations, you can't experiment on children for your projects. You'd have to get formal approval to do that. So minimum age of 2 and a maximum age of 77. So that's the variables all together, and the last thing that we'll just look at is if we were interested in splitting these variables over the groups, similar to what we did with the graphs, except this time we're going to get the numbers out. So back to basic statistics and display descriptive statistics. Let's delete all that out again. Let's just look at the time, and then if we click into the by variable option, you can see that now it gives us a whole lot more options because it brings all the categorical variables in. So let's have a look to see if there is a difference in the time based on the area. Okay, so we can see that the mean time to hold your eyes open inside was 23, nearly 24 seconds, and the mean time outside was 19. So the time is higher, the average time is high inside, but we don't know if this is just due to random chance, and if we did the same experiment again we'd get, you know, slightly different results, and the outside was higher than the inside, or if this is actually a statistically significant difference, and that's something that we will test later on to work out whether or not we could expect to get a similar difference if we ran the experiment again. And you can have a quick look through if you're interested. Similar standard deviations, again one's higher than the other, and similar minimums, 3 and 2 seconds. We're in the time to hold your eyes open now, not ages, so 3 seconds and 2 seconds, and the maximum times. So the maximum time inside was quite a bit longer than the maximum time outside. What would really be interesting would be actually if you could do the same test on each, both tests on each person, test them inside and test the same person outside, because it may be that this one person was just freakishly able to hold their eyes open without blinking, and it didn't matter whether they were inside or outside. And if there was a difference between inside and outside, you'd really be able to pick it up if you were testing the same person twice. Okay, so I encourage you to go through and explore both the graphs and the basic statistics. We've got your descriptives here and your tables, your tallying and your cross tabulation.